Hello everyone, welcome to Sangam tutorials. SP Gubbi online classes for NCERT 10th standard and CBSE 10th standard. So yesterday you had written a science unit test on light. So starting from types of mirrors, concave mirror, convex mirror, magnification, loss of that is refraction, loss of refraction, numericals on mirrors and numericals on refraction of that is refraction of light. So including the numericals on refractive index. So these were the topics covered in the test. So it is the test what it was given for 30 marks. So most of the students are presented very well. I am very happy and I feel proud of it. So it's a fantastic effort. But in spite of that, very simple silly mistakes, simple errors you have done it. So therefore to avoid that in the next coming test, I am going with this orientation for science test. So welcome you all. So let us go with the first question. So 1 mark questions, 3 were given. So define the term principal axis of spherical mirror. So principal axis. So principal axis is a line. So the principal axis is a line which joins the center of curvature and the pole of the mirror and which can be extended on both sides. This is the answer. Very simple. Principal axis is a line which is passing through the pole of the mirror. Most of you have written it. And principal axis is a line which cuts the mirror into 2 equal parts. Many of you have written it. It's not the right answer. The answer is near to the right answer, but it is not the right answer. So the right answer should be the line which joins the center of curvature of a mirror and the pole of the mirror and which can be extended on both sides is called the principal axis of a mirror. So this is 1 mark. State a condition for refraction of light entering from one medium to another. So maximum 90% of the students have written wrong answers for this. So state a condition for refraction of light. So when a light has to undergo refraction, the light has to travel from one medium to another medium. So this is the condition. State a condition for refraction of light entering from one medium to another means if a light has to enter from one medium to another medium, the refractive indices of both the mediums should be totally different. That means the light should travel between 2 media which are having 2 different refractive indices. So if the mediums have different refractive indices, then the refraction of light takes place. This is the condition. Okay. Refractive index of diamond is 2.4. What is the meaning of this statement? Very simple question again for 1 mark. So here refractive index of diamond is 1.4 means the speed of light in air to the speed of light in diamond is 2.4. This should be the answer. Or this can also be written in a different way. The speed of light in diamond, the speed of light in air is 2.4 times more than the speed of light in diamond. So this can also be written. So 2 answers can be written for that. Both are correct. So I will repeat. Refractive index of diamond is 2.4 means the ratio of speed of light in air to the speed of light in diamond is 2.4. That is the meaning of the statement. That's all. Many of you have written very wrong answers. Very few have written wrong answers. So please correct this. State loss of refraction. That is for 2 marks. So the incident ray, the refracted ray, and the normal drawn at the point of interface separating the 2 media at the point of incidence all lie on the same plane. This is the first law. So 1 mark you are going to get for that. The sign of angle of incidence to the sign of angle of refraction, right, for the given color of light and for the given 2 media is always a constant. So after writing this second law, you have to write sin I by sin R is equal to constant. So this constant is called the refractive index of the medium 2 with respect to medium 1. So this is the full answer you have to write. So whenever in physics, if they are going to ask you any laws, you have to write the law and and also you have to write always the mathematical form which is involved in that law. So for second law, the mathematical form is sin I by sin r is equal to constant, where C, that is constant, is called the refractive index of the second medium with respect to the first medium. This is what you have to write. So that is laws of refraction. So many of you have written just the incident ray, the refracted ray, and the normal lie on the same plane. That's all you have written. You have to write at the point of interference, at the line separating the two media, that is the interference, and also at the point of incidence. They all lie on the same plane. This is the first law. Second law, the sine of angle of incidence to the sine of angle of refraction for the given two media and for the given color of light is always a constant. So after that you have to write sin I by sin r is equal to constant, and this constant is called the refractive index of the second medium with respect to first medium. So this is how you have to complete the answer. So in future, if they ask you any laws regarding physics, you have to write compulsory their mathematical forms and explain the terms which are involved in that formula. Right. So fifth one is a beautiful 2-mark question, which is a numerical. Absolute refractive indices of glass and water are given. So absolute refractive indices of glass, that is Ng. Absolute refractive index of glass and absolute refractive index of water, both are given. So absolute refractive index of glass is 4 by 3. Absolute refractive index of water is 3 by 2. So why I am writing NWNG means it is absolute refractive index of water and absolute refractive index of glass. So G indicates glass and W indicates refractive index of water. So if the speed of light in glass is, that is VW, velocity of light in glass, VG. Velocity of light in glass is 2 into 10 to the power 8 meter per second. 10 to the power 8 meter per second. Okay. Find the speed of light in vacuum. That is, you have to find the value of C. You have to find the value of C, because speed of light in vacuum is represented by the letter C and water. So you have to find out VW is equal to how much? That is velocity of light in water. So you can go with these two things. One is Ng and Vg. You can go with this. So Ng is equal to C by that is Vg. So refractive index of glass is equal to speed of light in vacuum by speed of light in the glass. So Ng value is given, that is 4 by 3 is equal to C value. We have to find out C is nothing but the speed of light in vacuum we are going to get. So Vg is given, that is 2 into 10 to the power 8. So we have to go with cross multiplication. C into 3 is 3C is equal to 4 into 2 into 10 to the power 8. So 3C is equal to 4 2's it is 8 into 10 to the power 8. So many of you, what you have done is you put a bracket here. So 4 2's are 8 and 4 10's are 40 to the power 8. So they are all silly mistakes. Please avoid it. So 4 2's is 8. So C is equal to 8 into 10 to the power 8 by 3. So 3 1's are 3, approximately 2.7 times it goes. So it's equal to 2.7 into 10 to the power 8 meter per second. So this is the value of C, what we have got according to the refractive index of glass. According to the value of 4 by 3, that is, we have got the speed of light as 2 into 10 to the 2.7 10 to the power 8. Okay. So we find out VW. So that is velocity of light in water. So velocity of light in water can be found out like this. That is NW is equal to C by VW. So this is the formula. N is equal to, N represents the refractive index. So NW is equal to C by VW. So NW it is given, that is 3 by 2 is equal to C. We have just find it out. That is 2.7 into 10 to the power 8 by VW. So we have to find out. So 3 into VW is equal to 2 into 2.7 into 10 to the power 8. So VW is equal to 2 into 2.7 into 10 to the power 8 by that is 3. So VW is equal to 3 1 times, it is 3 0.9 times. So 0.9 is into 2 is 1.8 into 10 to the power 8 meter per second. So this is the velocity of lighting water. So this is the answer. So I hope if you have got this answer, this is the method. If you have not done it in the test, please write it down in your class workbook. Right. Okay, next is distinguish between real and virtual images. Very important question. Distinguish between real and virtual images. So we can go with this. So virtual image cannot be caught on a screen. That is, virtual image cannot be caught on a screen, but real image can be caught on a screen. So virtual image is always erect, real image is always inverted. So virtual images are formed by divergent light rays and real images are formed by convergent light rays. So these are the 4 very important points. So virtual images, it cannot be caught on the screen, real image can be caught on the screen. Virtual images are always erect and real images are always inverted. Once again, virtual images are formed by the divergent rays of light and convergent light rays of that is real images are formed by convergent light rays of light. So 4 points you can write for differences between virtual and real images. So every difference carries half a mark. So real images are formed at a point where actually the 2 light rays meet after reflection. So virtual images are formed behind the mirror where the 2 light rays appear to meet after reflection. So these are the 4 differences. So it's very important. You have to be very careful while writing answers. Okay, we'll go with the next one. Draw a ray diagram to show the image formation in a concave mirror when the object is placed between F and P. Very important. So in the last class itself I had shown you all the ray diagrams. So among them this was very important. So draw a ray diagram to show the image formation in a concave mirror. So let us take a concave mirror, so which is silvered at the outer surface so that it is reflecting. So let us pass a line through the mirror where it is called as the pole. This is the center of curvature. In between the center of curvature and the pole we have the principal focus. So draw a ray diagram to show the image formation in a concave mirror when the object is placed between F and P. So object is placed between F and P. So we keep the object here. So many of you have not named the object itself. Many of you have not named the object. So please name it. So it is A and B. So one of the light ray travels parallel to the principal axis. After reflection it passes through the focus. And the second one is we cannot pass it through anywhere. So therefore we are going to make it to pass through the center of curvature. Right. So it passes here. So here these light rays, that is a light ray passing through the center of curvature, as it hits the mirror, it is going to retrace its own path and the light ray is going to travel like this. So these two are diverging light rays and they will never meet each other. So therefore we are going to produce these light rays beyond the mirror, and these two light rays we see that they meet at a point behind the mirror. So this is the image form. So many of you have not named the image also. So it should be named as A dash and B dash. So this is okay. You have to put the rays, in which direction the light ray is traveling. So virtual light rays are always represented by dotted lines. So this is the ray diagram. So now you have to write the position. So where it is formed. So it is formed beyond the mirror. It is formed beyond the mirror, that is behind the mirror. Okay. So what is the nature? So nature of the mirror, the nature of the image formed is virtual. So if the image is virtual, it is always erect. It is virtual and erect. Next is size of the image. So when you compare the size of the image with the size of the object, it is enlarged. So it is enlarged. That is, image is enlarged. So this is the thing you have to write. So for 2 marks. So this will be for 1 mark and this will be for 1 mark. So be careful. Write the name of the image. Write the name of the write the name of the object. Write the name of the image. So put wherever the light rays are traveling by arrow marks, and then write the properties. So this is compulsory. Use pencil and scale, please. Many of you have drawn your ray diagrams just by free handwriting. See, this is not the way of learning. You have to be very disciplined. Without discipline, nothing can be done in life. If you want something, you want to learn something good in physics, you have to be bound by the discipline of physics, and also in mathematics. That also applies. So this is very important. Okay, this is for 2 marks. Convex mirrors are used in rear view mirrors. Why? So it was the most important question. Usually I repeated a number of times during the class. So why it is used? Why the mirrors are used in that is convex mirrors are used in the rear view mirrors. So convex mirrors always gets an erect, diminished image under a wide range of view. That's all. That's all you have to write. Not more than that. Convex. Many of you have written convex mirrors are having surface that is silvered at the inner surface, so that they are reflecting at the outer surface. See, I am asking you a very simple question. Convex mirrors are used in rear view mirrors. Why? That's all. I don't want to know what is a convex mirror. It's none of the answer which is involved for this question. So it's not the answer for this question. So very simple. You have to write only 2 lines. Convex mirrors always get an erect, diminished image and has a wider range of view. That's all. That's given in the classwork book. It's in the notes. That's what we teachers always insist you. Please be updated. Read the things, study the things the day itself. Don't prolong it. All these things why teachers tell you, because you will not be able to perform well in the test. That's the only reason. So okay, we'll go with the next question. I will repeat if you want the answer once again. So convex mirror always gets an erect, diminished image, has a wider range of view. This is the answer. Okay, we'll go with the next 9th question. Very important. Numerical on convex mirror. A convex mirror used as a rear view mirror. Convex mirror used as a rear view mirror in a car has radius of curvature 3 meters. Radius of curvature 3 meters. So R is equal to 3 meters. Radius of curvature is given. Okay, right. So if a bus is located at 5 meters behind the mirror, so that's the object distance. The object distance is u is equal to minus 5 meters. Object distance is minus 5 meters. You have to take it, and from the mirror. Find the position, nature and size of the image. So you have to convert this into that is focal length. So f is equal to r by 2, that becomes 3 by 2. It's approximately 1.5. So here we have to check whether they are positive or negative. So here a convex mirror is used. Therefore focal length is always focal length for a convex mirror. So this is a convex mirror. So this is silver at the inner surface. So this is the center of curvature. This is principal focus. This is the pole of the mirror. So focal length is between f and p. So whatever we measure it from the pole of the mirror in this direction. So focal length is positive in case of a mirror. So f is plus 1.5 itself, and u is minus 5 meters. That is the image. The convex mirror used for a rear view mirror in a car has radius of curvature 3 meters. If a bus is located 5 meters from the mirror, so behind the mirror, that is bus is located somewhere here, object is somewhere here. So therefore direction of light rays in this direction, and you are measuring something in this direction. So therefore u will be negative. So u is equal to minus 5. So you have to find the position, nature and size of the image. So in a convex mirror always the image is found between P and F. That is erect and vertical. So therefore you have to find the position, nature and size of this image. So we have to find out the value of V. V is equal to how much. So we can use mirror formula. So by using, nobody has done this, by using mirror formula. Nobody has written this statement. Just you have put the formula and you have substituted the values. You have went with the answer. See, getting the answer at the end of the problem is not the criteria. How you reach, in what style, what way you are going to reach to the problem, that is the solution of the problem. That's the important. That's the importance, right? So 1 by f is equal to 1 by u plus 1 by v. So 1 by f, we have to find out the value of v. So therefore we will make it as a subject. So 1 by v is equal to 1 by f minus 1 by u. So 1 by v is equal to 1 by f is 1 by f is 1.5 minus 1 by u is 1 by minus 5. So keep it inside brackets. So 1 by v is equal to 1 by 1.5 can be written as that is okay, let it be like that. 1.5, 15 by 10 we can write. 1.5 can be written as 15 by 10. So 5 2s are 5 3s are, so this can be written as 3 by 2. This can be written as 3 by 2. Minus into minus is plus 1 by 5. So 1 by 3 is equal to 3 by 2, if you take the reciprocal, it becomes 2 by 3 plus 1 by 5. For 3 and 5, LCM is 15. So V is equal to 15. So 2 by 3 into 15 is 10 plus 1 by 5 into 15 is 3. So that becomes 10 plus 3 is 15, 13 by 15. So V is equal to approximately, that is the distance of the image. V is approximately, that is 1.15 meters. So this is the value of V. So V is positive, you can see, because the image what you get here is virtual and erect, and it is located in the direction of the light rays. So therefore the value of V what you are getting is positive, and it is the right answer. So you have to find out the next thing, that is you have to find the position. Position is, we have got natural size of the image. So let us find out the size of the image. So if we have the value of V, we have the value of U. So magnification can be written as minus V by U. So we have to go with the size. So we can go with H dash by H. So better minus V by U is better. Okay, so M is equal to minus, formula is there. So V value what we have got is, it is 1.15 by U value is minus 5. So M is equal to, so minus and minus cancels, 1.15 by 5. So M is equal to approximately it is 0.23. So in order to tell the nature and size of the image, always we have to take the help of the magnification. So here the size of the image, inside the mirror is 0.23 times the image of the object. So you have to write the statement here. The size of image is 0.23 times the size of object. So this is the thing. So image, as we know, it is virtual and erect. So image is virtual and erect. So this is the problem. If you have not done it, please copy this in your classwork. Most of the students have done some numerical errors. Please be careful with minus sign, plus signs. Be careful with that. Okay. Write the properties of image formed by convex mirror. So convex mirror, the type of images formed by convex mirror. So images are always virtual and direct. Just now we have seen. Image is smaller than the object. Image in a convex mirror is always smaller than the object. Image is formed between P and F of the mirror. So we have many ray diagrams. In all the ray diagrams, you can see that the image is always, it will be in between P and F of a convex mirror. As we move the object away from the mirror, so if this is the mirror, as we move the object away from the mirror, the image of the object goes towards the principal focus, because when the object is placed at infinity, the image is formed at the principal focus. So when you bring the object towards the mirror, the image will start coming from the principal focus towards the pole. So that's the thing. So you have to remember this. When you bring the object, this is the convex mirror. This is the convex mirror. If you bring the object, if you take it as infinity, so if this is P and F, so here when the object is placed at infinity, image is formed at principal focus. So when you bring the object towards that is the mirror, the image starts moving towards the pole of the mirror. That is, it will be in between P and F, but it will move more towards the pole of the mirror. If you take the object away from the mirror, the image of that object will be moving towards F. So if the object is here and the image is here, if the object starts moving towards the mirror, the image will be moving towards that is pole of the mirror. If the object moves towards the infinity, the image will be moving towards something like this. If the object moves towards the mirror, the image will move towards the pole. If the image goes away from the mirror, the image moves towards the principal focus. So this is the thing you have to remember. See, that is what you have to observe in ray diagrams. Observe the ray diagrams, practice that. So that's the reason behind that. So we'll go with the next question here. Define the term magnification. Write the formula for magnification of mirror, explaining the symbols used in the formula. Right. So magnification of an image is defined in two different types. Ratio of height of the image to the height, ratio of height of the image to the height of the object is called as the magnification of the image. That is called magnification. So magnification is represented by small letter m. If h is the height of the object, h dash is the height of the image, then m is equal to height of image by height of object. That is h dash by h. This is one of the way. So the ratio of height of the image to the height of the object is called as the magnification of the image. It is represented by the small letter m. So this is the small letter m. So after that, what you have to write is, if h is the height of the h dash is the height of the image and h is the height of the object, then m is equal to height of the image by height of the object, that is h dash by h. Or magnification can also be defined as the ratio between the image distance and object distance. So m is equal to, if v is the image distance and u is the object distance, then m is equal to, that is, you should write like this, image distance by object distance is equal to minus v by u. So these are the two ways you can answer this question. So both the ways you should present in the examination, because the question is asked for 3 marks. Okay, we'll go with the next one. The problem again. An object 4 cm in height is placed at 15 cm in front of a concave mirror of focal length 10 cm. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Find height of the object. So this is the problem done in the class 1 book. So it is already done. So answer is v is equal to minus 30 centimeters and h dash is minus 8 centimeters. I hope you have got this. So you have to present in the same manner, same discipline what I have presented like on the board. Right? You have to 100% follow me regarding the presentations. Okay. So here v value is minus 30 centimeters and h dash is minus 8 centimeters. Right. So we'll go with the next question, that is application level. See, in every test, see the entire question paper what I have given for the test, it contains questions on your knowledge, questions on your numerical abilities, questions on skill, that is the ray diagrams, questions on your memory, because you are going to memorize laws and you are going to write it. So also the questions will be based on applications. So you are going to apply the things what you have learned in your textbook to your daily life. So that's one question at the last 4 marks it is given. A student wants to project image of a candle flame on screen 60 centimeters in front of a mirror by keeping the flame at 15 centimeters from its pole. See, the question clear cut indirectly tells you what type of mirror he is going to use. So, a student wants to project image of a candle flame on screen 60 centimeters in front of the mirror by keeping the flame at 15 centimeters from its pole. Then he should use a concave mirror, because if this is the concave mirror, what distance he is going to place the candle, that is candle, so at 15 centimeters from its pole. So this is the pole, and at distance of 15 centimeters he is going to keep the image, that is candle flame. So candle flame can be taken like this. So it's a candle flame, he is going to place it here. So at a distance of 15. So this becomes U, because U is the symbol representing the object distance. Next, he wants the image of this candle to be at 60 centimeters from the pole of the mirror. So the candle will be somewhere like this. So this should be the candle. So and this distance is 60 centimeters. 60 centimeters, and this is the value of V. So the compulsory the mirror should be a concave mirror. So first question answer we have got. Write the type of the mirror he should use. He should use a concave mirror. Next, find linear magnification of the image produced. Linear magnification is given by M is equal to minus V by U is the linear magnification. So M is equal to minus V, that is minus of this value is V, that is minus 60 by U value is minus 15. Okay, so M is equal to Y minus 15 because you are measuring something against the direction of the light rays. So minus into minus is plus 60 by minus 15. So answer is minus 4. So M is equal to minus 4 is the linear magnification. So the image of the candle is 4 times the image of the object. That means that. So why we get a negative sign? Because one of the object is above the principal axis and the image is below the principal axis. Therefore, the magnification should be negative. So in concave mirrors, magnifications will be negative, which is very important. I have discussed in the previous classes. Find the distance between the object and image. So here is the object and here is the image. So they are asking you this distance. This distance. They want this distance. So it's very simple. 60 minus 15, that is 45 centimeters. So 45 centimeters is the distance between object and image. Okay. Draw a ray diagram to show the image formation. So I have to draw a ray diagram for this. So if this is the object, you can take it as AB here. You can take it as AB. So one of the light ray should travel parallel to the principal axis and pass through the principal focus. So let us imagine that this is the center of curvature and this is the pole. This is the principal focus, that is F. So it passes through this. Okay, so this is the reflected light ray. Another light ray will make it to pass through the principal focus itself. So this is the light ray formed. So maybe the candle is going to, the image is formed at this distance. This is the image. So it is 60 centimeters. So you have to write the ray diagram. So we have taught you in the previous classes, you have to draw the ray diagram for this. When the object is kept between C and F. So then only you are going to get the magnified image, isn't it? Because M value you are getting as minus 4. So if you want the image to be magnified, it is enlarged when compared to the object, you have to place the object in between C and F only. Right? So that it will be, you will get an enlarged image. So this is the ray diagram for that. So still there are certain areas where you are weak, where I am observing that. So please write the technical answers. Don't use your common English, right, to write physics answers. Write technical terms, involve technical terms in writing the answers. Be mathematical while writing physics answers. So you should have a mathematical mind for writing physics answers, so that you present the science and physics answers in a very systematic order and scientific order, right? So please maintain some cleanliness in the paper. You just strike it everything, you write somewhere, you show arrow marks. Sir, this is not the thing, please see there. So don't do such things, right? If the thing, if you have done some wrong, no problem, right? Strike the things, take a new paper, start doing it, because this is not a real classroom. I have given you 1.5 hours for writing a 30 marks test, it's more than enough. So why I gave you more time? Because I wanted you people to present in a very systematic manner, right? And I observed that one of the student, for the second question, write a condition for refraction of light entering from one medium to another. I observed directly the student has written. That means what he has done is he has taken the question, he has typed it in Google, he has got the answer in Google, he has written all the answers what he has got in Google in the answer sheet. See, please don't do these things. You are a student, study well for the test, prepare well for the test, present the same things in the test. If you get less marks, no problem. I am telling you, no problem. Right? If you get less marks, it's not a problem, because you are all not masters. Still you are students, you are learning. There will be certain learning disabilities. Maybe you may not be able to present well. So all these things will get corrected in a stipulated time. In the coming days, you are going to become masters in that. But the thing is, you should not lose hopes. You should not go for some other way of writing answers, because our teacher is not saying, nobody is saying, I can do anything I want. So this is not the way. Be systematic, be disciplined. So the meaning of discipline is, when a teacher is in front of you, how you will be. You should be like the same when nobody is seeing you. That is discipline. Right? So maintain discipline. Write correct answers, answer to the point. And please take the test. Some of the students have not taken the test also. So please take the test. So tests are given to correct you and make you masters in the subject, not for insulting you or hey, you don't know that, you don't know this. It's not like that. It's a challenge, a small challenge for you, right? It's okay. If you have got less marks, it's okay. Take some time. WhatsApp me, sir, we are all ready with the right chapter. Give us a test. We'll write it. Yeah, it's okay. I'll give you a test, present in a very systematic manner, score marks. What is there in that? Right? So don't go for other illegal methods for writing a test. That's all. Right? So I hope you enjoyed the entire orientation session. So I wish you all the best for the coming days. Don't lose hopes. Carry with your work. Right? So don't depend upon marks for scoring marks. Marks is not the criteria in your life. Knowledge is the criteria. So gain good knowledge. Marks will 100% follow you. Right? Wish you all the best. Stay home, stay safe. Keep learning.